Okay, let's get back to looking at derivative limits. Now, a few videos ago, we had a problem where we could decompose. It was tough, but it made life a little easier when we finally did it. This time, we can't decompose. So we just got to go through. We want to find the derivative of y when y equals this guy. So we do the limit delta x goes to 0. This is f of x plus delta x minus f of x, of course, over delta x. Now this time we have to, well, what we do is we go ahead and at least, the least we can do is bring the delta x here where my cursor is, and also here where my cursor is. By the laws of algebra, we can do that. So put delta x here and delta x here. So, all else fails, we can at least do that. So now what's next? We need to get common denominator, and it's going to be a little painful. We couldn't decompose. So both denominators obviously have delta x, so we got to furnish what's missing. So this 8 times x plus delta x has another term multiplied on, namely this 4x squared minus 3, and this 8x has a term multiplied on, namely this jalopy right here in brackets. Okay, so here's all this. And then that lets me do my common denominator of delta x times jalopy times 4x squared minus 3. And, well, up here you got to do some painful algebra. By associativity, you can multiply x plus delta x here times the entity 4x squared minus 3 by doing distributive FOIL. And after doing some algebra, this x by FOIL, x times 4x squared is 4x cubed. X times negative 3 is minus 3x. Delta x times 4x squared is just 4 times delta x times x squared. And then delta x times negative 3 is minus 3 delta x. And then, well, after that, let's see. Now there's a minus 4x cubed that let's see, minus 4x cubed. Okay, oh, now where am I going now? Now you got to do, you FOIL, now x plus delta x squared, you do use the perfect square formula, or you could FOIL it over itself. You would have had x squared plus 2x delta x plus delta x squared, but you multiply everybody by 4, and so you get, multiply everybody by x and by 4, so I would have had x squared plus 2x delta x plus parentheses delta x squared, but I'm multiplying everybody by 4x. The x is right here, the 4 is right here. And so I get, and also the negative as well. So this negative, this x, and this 4, that's the same thing as saying negative 4x. And so x squared becomes negative 4x cubed. 2x delta x becomes negative 8x squared delta x. And then delta x squared becomes, minus 4x times delta x squared. And I did forget my 4 there. Sorry about that. So there's my 4. And then, let's see, what else is happening here? And then plus 3x. And, yeah, because, now guys, but this negative and this x is going to hit this negative 3, but the 4 is not going to hit it. So this is plus 3x. Be careful, it's not plus 12x, because this 4 is only hitting what's inside here. Now, the negative and the x, it's hitting everything in here, but this 4 was only hitting this perfect square polynomial. So the negative x is going to hit this negative 3 and give me plus 3x. That's tricky, be careful. Okay, and so now the 8, notice I didn't address the 8s. I yanked 8 all the way out here, and I did 8 times everything in brackets here. I didn't want to fool with 8 right now, okay? Since 8 multiplies everybody, we may as well just yank him out here to the side. So I yanked 8 out here, and that let me go freely through here and ignore this 8 right here for the time being, and also ignore for the time being this 8 right here. So I just, by algebra and arithmetic, I yanked 8 out. So I only focused on these two, and I focused on everybody here except for this 8 right here. Because for the time being, 8 got yanked out. Thankfully. I'm glad, to be honest. Did I have to do that? No, but it just saves me from big numbers and from headache. Now, let's see. This negative 3x and this positive 3x are going to cancel. Does anything else cancel? Let's see. Oh, yeah. Sure enough, yeah, it does. The 4x cubed and the minus 4x cubed will cancel. Anything that doesn't have a delta x in it is going to get canceled. And if and only if it does not have a delta x. So the only things that survives are my delta x terms. So I've got this negative, well, not this, mind you, but this right here, rather. So this negative 3 delta x, I've got the minus 4x squared delta x from right here. Let's see, is that right? Actually, yeah, that should be squared. Sorry, guys. Oops. I keep getting clumsy. Because we had 2x delta x, and then it bumped into minus 4x, and it became minus 8x squared. You know what? No. That's not x squared. That was x to the 1 in the first place. I had that right in the first place. Never mind. So that's minus 4x delta x squared. Okay, now what did I do? Oh, here we go. Negative 8. Here's a negative 8x squared delta x, and here's a positive 4x squared delta x by commutativity, and that those can be combined to make negative 4x squared delta x. Okay. And then, now what about my x to the 1 times delta x squared? I've still got to account for that. So I've got minus 4. I've got a minus 4 of that term here, where x is to the 1 and delta x is to the 2. Is there any more of these? No, not really, is there? So that really should be a minus 4 there. Okay. And so over my denominator, so there's that. And now, forgetting that minus 4, you can't forget it. You need to remember it. It did mess up my answer, my final answer, but it needs to be there. So there's that minus 4. And now what I do on the next step, guys, what I do is each of these guys has a delta x in them. And notice I'm dividing, there's a delta x by himself down here. So on this next step, I can divide delta x off of these 3 guys up top. That kills this delta x down here. That's the golden goose. And then that's just negative 3. And that's just minus 4x squared. And that delta x squared that was with that minus 4x is just now delta x to the 1. Okay, so you divide off the delta x, and here it's just business as usual. Now that 8 can come all the way out here, by the way. And I illustrate that. So we just take the 8 all the way. You can take the 8 all the way out here. Is there anything else that we do? No, not right off the crack of the bat. So I just illustrate what I can do with this 8. You can take it all the way out. And now, lo and behold, since you remember the golden goose, we canceled the delta x's, we can throw delta x equals 0 into delta x. And so this term right here is dead. I still need my 4 there. I'm sorry about that. The term is still dead, but I want to be correct. So I throw in 0 for delta x, and so this minus 4x delta x is dead. That's why it didn't hurt me. Well, I still shouldn't have forgotten my 4. That's not an excuse. Please don't do that when you do your homework. Leave alone a test. But anyway, so this goes to 0. Now I throw 0 into here. That's just going to be 4x squared minus 3 times itself. 4x squared minus 3. Oh, okay, here we go. And so I get, well, now I bring that 8 back up here, and so I get 8 times negative 3 minus 4x squared over 4x squared minus 3, 4x squared minus 3. And I just now, guys, it's tempted to think that the top will cancel with the bottom, one of the bottoms. It does not. Even if I took out a negative 1, this would only, if I yanked out a negative 1 and made 8 negative 8, I would still have positive 3 plus 4x squared. That's no kin to 4x squared minus 3. No cigar. Close, no cigar. So nothing cancels. You may as well just go ahead and distribute the 8 through and get negative 24 minus 8 times 4 is 32 x squared over, and then somebody times himself is just that somebody squared. So this guy squared on the bottom. And that's it for that example. And again, let's just recap. I know that was heavy. So I get I get my common denominator, and I take out that 8. I don't bother, I take that 8 out. Okay, right here. So I take that 8 out, and now let's see, in the middle I had 2x delta x, then this negative, this x and this 4 made that negative 8x squared delta x. In the end, I had delta x quantity squared, but then that gets multiplied by a negative 4x. So it's negative 4x delta x quantity squared. And then I forgot my 4 a minute ago, but we amended that in a few minutes ago. So there's that. And then now remember, this 4 doesn't have anything to do with this minus 3. However, the negative x does, and that negative x multiplies that negative 3 and gives you positive 3x. That's tricky to some students. And here I just did FOIL, and then here I just did FOIL straight up. Okay, if I would have showed every little algebra step, guys, this example would have been pages long. Okay, can you appreciate why I wanted to be a little bit brief? I try to show as many steps as possible, but I would have went crazy on this one. Now, as it turns out, I've not showed you the shortcut formulas yet, but in my mind, I can, later on you'll be able to check this guy by shortcut and see if he's correct. You don't know that shortcut yet. But anyway, my answer is good to go, so there's that. And I just wanted to show off a hard algebra one. Sometimes a rational expression, this looks humble, but it was actually a hard derivative to do. But anyway, there's that. And now here's another one. We get like y equals 5 over radical 6x plus 7. Now here there's really no easy way out. You just do f of x plus delta x minus f of x over delta x, limit as delta x goes to 0 thereof. So we're doing the limit of the difference quotient to get the derivative as always. Now you got to get a common denominator, and it's a royal pain. You have to multiply this guy by this guy, cross diagonal, this guy times this guy. We've been doing that really in times past. But so you get this guy minus this guy over the same common denominator. I just go ahead and cut to the chase. I don't even leave them separated. I just bring them together. And so we get, well, let's see. What do we got? Oh, you can, by the rules of algebra, you can just, this delta x goes right here where my cursor is. So there it is. You don't have to have a nested fraction at least. It's still not fun, but at least life is better. Now the next thing I do is I factor out the 5. That wasn't, and then I take the 5 all the way out here. So I've not done anything at all heroic here and here, okay? Now the next thing I've got to do is get honest. And I've got to conjugate the numerator. That's not always fun. But then I do A. Think of this as big A. Think of this as big B. So A minus B times A plus B. But if I stick A plus B up here, I've got to stick A plus B down here. It just is what it is. You got to do it. I know this is a little unwieldy. But remember, A minus B times A plus B by difference of squares is A squared minus B squared. But if I square radical 6x plus 7, I get plain Jane 6x plus 7. If I square this jalopy right here, if I square this guy right here, if I square the square root of whatever, I just get whatever, which is this guy in brackets. Now, you need these brackets because you're minusing this whole thing here. Watch out for the nasty algebra and arithmetic, okay? So the 5 is out here, thankfully. So we get, now these left parentheses, we can drop them. The bracket, we got to be more careful. Now, inside the bracket, we would distribute in the 6, we would have 6x plus 6 delta x plus 7. But then that minus sign is going to distribute all the way through, and we get minus all that. Minus 6x minus 6 delta x minus 7. So watch out for that. But lo and behold, guess what, guys? Anything on the numerator that doesn't have a delta x in it is going to get canceled, just like it always has been before. 7 and the negative 7 cancel. The 6 and the minus 6x cancel. All you're left with is negative 6 delta x up top and your stuff on the bottom. But guess what? delta x is vulnerable. The delta x here and the delta x here will cancel. You're just left with negative 6 over this stuff, and that's going to set the stage for you to actually go in and let delta x equal 0. And that'll be the next thing you'll do afterwards. So then we can go in and plug in delta x equals 0, but hey, that's just going to make this 6x plus 7. And this was already 6x plus 7 here. This becomes 6x plus 7 when we plug in 0 for delta x, and ditto for this guy right here too. And so we get, well, let's see, what do we get? So we get, now if I multiply, so I just get radical 6x plus 7 squared times, now here we're multiplying, here we're adding. This is very different than this, because here we're adding, and here we're multiplying. Okay, watch out. So here we just get, 6x plus 7 times himself is inside the radical 6x plus 7 squared. And then now here, 6x plus 7 plus himself is 2 times radical 6x plus 7. Watch out. Okay. But hey, the square root of whatever squared is just whatever. You know what? I don't take that approach here, do I? Yeah, I could have done that. This would just be plain Jane 6x plus 7 here. But notice what I do is I go ahead, you see this negative 6 here and this 2 here? Negative 6 divided by 2 is neg 3. And what I do is I'll leave the radical intact, and I bring these together. I do 6x plus 7 parentheses squared times 6x plus 7. Now if I brought these together, I'd need a parenthesis around the 6x plus 7 here. But thingamabob squared times thingamabob is just thingamabob cubed. So radical thingamabob squared times radical thingamabob is radical thingamabob cubed. There's several ways. Another way I could approach this, I could have just called this 6x plus 7 plain Jane, and so I would have had 5 times neg 3 over the product of plain Jane 6x plus 7 times square root 6x plus 7. But anyway, so let's go down here. Now I do 5 times neg 3 to get neg 15. I'll leave the negative out here though. You could put it up here with the 15 if you wanted to. What else? And so my final answer, this is a negative sign right here. I'm sorry, the font is small on that one. So it's negative, then this is a minus sign, 15, and then that's 6x plus 7 to the negative 3 halves power. Now, another way to write this, another thing I could have done, and this might be worth showing off, is if this just bothers you, and it might bother some of you, is go ahead and cancel and get that negative 3. That was a good thing. But then here I would just get 6x plus 7, you'd need a parenthesis, and then times, here's what I was talking about, radical 6x plus 7. Okay, that's what I was talking about. And I know that's what some of you is probably itching to do. And then you can go ahead and you can make that, well, you can just cut to the chase already and make that negative 15 up there. And if you want to yank that negative out to the side here, that's fine. So you can start, and then we could rationalize, and well, we would get the negative of, well, let's see, 15 over, now if I rationalize, what that's going to be is, I'm going to multiply top and bottom by radical 6x plus 7. So, I've got to watch my clock, I'm running out of time. But then that's going to give me, what that's going to amount to, if I rationalize the denominator, I'm going to get 2 6x plus 7's plain Jane downstairs, which is going to be 6x plus 7 squared. So here's probably the what might be some professor's favorite right here, depending on her or his style. But what I did was I went this way. You could go this way if you'd rather. This may be the neater way to go. What it is, if I stick a rad 6x plus 7 up here and a rad 6x plus 7 down here, that new rad 6x plus 7 is going to bump into this old one and give me plain Jane 6x plus 7, but that's going to bump into this other plain Jane 6x plus 7 and give me the square of it. But anyway, that's all, guys. Thank you.